Hello friends, welcome to session 7 on orthographic projections. We are continuing with orthographic projections of machine components. Now this is machine component problem 5. See here, they have given one machine component in this way, okay? And they have given the direction F also. You have to draw the front view, you have to draw the top view. Since right view is predominantly seen, you have to do the right view on left profile plane. Okay, this is the thing to be done: front view, top view, and right view. That's what I given: front view, top view, right view. As I told you earlier, always in the orthographic projection, this will be given. This isometric object will be given with all the dimensions. See the direction of front view. With reference to that front view only, you have to decide. Front view compulsorily in that way only. As you see in the front, in this direction, how it appears in the front, that is front view, how it appears in here, top view, and then the right view on left profile plane and all that. Okay, the direction is all important. Okay, first you identify the direction. Okay, now you see here, this is the problem given. You see here, carefully you look at the dimensions. This is the problem given. See, this is some simple machine component. Carefully analyze, because here in the entire chapter here you have to carefully take the dimensions. You can't miss the dimensions. You can't unnecessarily assume the dimensions and all that. The dimensions only if it is missing, then only you can assume. Okay, now front view has to be drawn, right view has to be drawn on left profile plane, top view has to be drawn. That is why where you draw xy line, x1, y1 line, VP for writing the front view, HP for writing the top view, okay, for HP for writing the top view, LPP for writing the right view on LPP, okay. Now as you are aware, as I've been telling you again and again, when you're looking from front view here, you are assuming VP to be behind this object and your direction of vision is perpendicular to VP. As a result, this entire surface will be seen in its true shape in the front view. Okay, you can write it as it is. You can write it as it is. And while writing the top view also, when you are writing the top view, the HP is assumed to be below this object. Horizontal plane assumed to be below this object. When you are looking perpendicular to HP, this surface will be seen in its true shape, and this surface will be seen in its true shape. This surface will be seen in its true shape in that way. Okay. Now anyway, you see here. This is, I'm concentrating, let us say, on front view. This is 119. Okay, you draw 119. Okay, this you draw 119, darken it. Okay. This you see here. How much is this you see? This is 41.5. Anyway, this entire thing is seen in its true length, the true surface, as seen as true surface in the front view. At least you can concentrate on that. Okay, this is 41.5. Go 41.5 above. Then you see this distance. This distance, if you see here, I think this distance is 23. Okay, see here, from here I have given 23. If you follow the line here, this distance is 23. You take 23 from here. Okay, 23 here. Anyway, that if you project it, the top view has shown this distance. This is 23. Then you go up by 15.5. Okay, this distance is 15.5, which I have shown here, 15.5. In that way, you go 15.5 here. Okay, once you go 15.5 here, what is this distance you see? If you see the distance, this distance, carefully watch. The distance from here to here, I have given 22. Can you follow? The distance from here, this point to this point is 22. In that way, this distance will be 22. Okay, this distance will be 23, this distance will be 22. Okay, and as you are aware, when you are looking from the front view, this entire horizontal surface, okay, this entire horizontal surface is perpendicular to VP, okay, because VP is just behind us. As a result, this entire thing will look like a line. That is what I have drawn here. Okay, please follow. After this horizontal surface okay, is perpendicular to VP and will be seen as a line in the front view. In that way, this you do. Up till here you do. This is 59. That is from here to here, it is 59. You draw a horizontal line only. Okay. Then you come down. This distance is 38. You come down. And as you are aware here, this also you have to draw a line, because when you are doing from here, okay, this is again a surface which is perpendicular to VP and will be seen as a line in the front view. This entire surface, this trapezoidal surface, what you see is in the front view, it is perpendicular to VP. When the surface is perpendicular to VP, it will be seen as a line in the front view. As a result, it will be 38. Okay, this will be 38 and remaining is 15. There is nothing here. Remaining is this you draw. Okay, this you draw 15, because this anyway, this is a true surface only, which you already drawn. Okay, this is a true surface only. This is up to 119 already done. Okay, this distance also, you know, this is 19. Okay, this is 19. In that way, this you have completed. This completes the front view of the object. Okay, carefully see here. First you draw 119, then 41.5 has been given, you take this. Then this 23 has been given, take this. This 15.5 has been given, take this. This is 22 has been given, take this. And this surface, when you're looking from here, this entire surface will be seen as a will be perpendicular to VP. So that's why it will be seen as a line up till this point. Okay, that is 59 from here. This will be 59. Then after that, this will be again, this entire thing will be seen as a line in the front view, because it is perpendicular to VP. Again for 38, you draw this line, and this is anyway is 15. In that way, you are completing the front view. Okay, once you complete the front view, you complete the top view. Top view is much faster. Take the projectors down, take the projectors down, take the projectors down, take the projectors down, take the projectors down. You make the projectors all down. Once you do this, okay, as you know here, this distance is 59, no? If you imagine VP to be behind this object, this will be the distance in front of VP from this corner. You take any distance here. After that only the projection will start. Whether it starts from 10 mm or 20 mm, this top view won't change. That is why I have assumed some distance. Whatever distance I assume here, okay, whatever distance I assume here, you should assume the same thing here. Okay. Now, you assume the same thing here also. Okay. Now, this is 59. Once it is 59, this is 119 already has been drawn. 59 by 119, you draw, complete the rectangle. Okay. Now, as you see here, this surface, that is this edge, this surface is seen in its true shape in the top view. That is why draw a line. This is a true surface. You draw an edge here corresponding to this. Okay. Then, when you're looking from the top, this particular thing will be seen in its true shape. Okay. That is why this also you draw in its true shape, because this is 25, this is 59, and draw this way. That means this entire surface in the top view is a true surface. That is why you concentrate on drawing the true surface here. Okay, you concentrate on drawing the true surface here. In that way, this portion is completed, and this portion, no, you don't worry about that. Once you do this portion, though it is an inclined surface, this is seen in the top view, but this surface is not in its true shape. But you are not worried about this, because this edge is correct, this edge is correct, this is an apparent surface. Let it be as it is, because you have concentrated on the true surface. This you have done. Okay, this you please observe. I tell you this surface is seen in its true shape in the top view, true surface, that I have drawn. Okay, this is 22 and this is 25. In that way I have done. Okay, next this surface anyway is perpendicular to HP also. Okay, this entire thing is perpendicular to HP. This will be seen as a line in the top view. That is what I have written here. Okay, without without getting confused, you draw this line perpendicular to HP. Okay, once you draw this is anyway true surface. This is 15, no? This is 15. up to 59, this entire surface, this is a true surface because you are looking from the top. From the top, the HP is assumed to be below this object and the direction of vision is always perpendicular to HP. As a result, this will be seen in its true shape in the top view. That is what I have written here. I think the top view is clear. Front view we have completed. Okay. Now you concentrate on the side view now. Side view completion, it's better I told you, this distance, whatever is this distance, you take it here and start drawing the side view. Okay, when you're looking from here, right view on left profile plane, this is 59. You take 59. Okay, this you take 59. Height, whatever is this, 41.5 plus 15.5, I've already done. You take the projector from here, you draw this. You draw this rectangle. Whatever you get here, this you draw. This is 59. This is 41, 51, 56, 57, I think. This is 57. Okay, 41.5 plus 15.5. In that way you draw. That means this rectangle, this you completed. This is when you are looking from here. This is 59 plus this 38 plus 19. That is 57. Okay, this you are completing. That is 59 here. And this height is always take the projectors from here only. In that way, you complete this. Now you observe this. When you are looking from here, this surface is in its true shape in the side view. That is, in the right view, which is written on left profile plane, this is true surface. How to locate that is, from here, this is 25, no? From here you take 25 and from this to this corner, okay, from this corner, this to this corner, that is this to this corner, you draw a line and in fact this will be in its true shape. Okay, once you do this, okay, then even this, no, this surface also is this surface, since this left profile plane is assumed to be placed behind this object, okay, behind this object, and your direction is this, the visibility is, that is your direction of vision is perpendicular to LPP. In that way, this surface is in true shape, this surface is in true shape, this surface is also in true shape. In that way, see here, this is 59, 19, this you already done. Once you do this, this already rectangle has been completed. Okay, this is 59. Okay, this is 59, this is 57, I think. In that way, you have completed. And this is the true surface. That is, you take 25 and draw this line. Okay, to this corner. Okay, you corner. This is the true shape anyway. And the back surface, this surface is again drawn in its true shape here. That you draw. That means it's more or less completed. But when you are looking from here, this back edge, no, this back edge, which is at a height of 15.5, that is this one cannot be seen. Okay, cannot be seen in the front view. That is why you make this as dotted. Did you follow? When you're looking from here, this edge which is going here, that is this top surface. When you're looking from here, that is right view, it will be perpendicular to LPP. It will be seen as a line in that, but that line cannot be seen. Hence, you make it dotted. Otherwise, also you can imagine the edge going from here. Okay, edge going from here cannot be seen. Okay, in that way, the side view also has been completed in all respect. Here, you have drawn the front view without any problem. You have drawn the top view without any problem. You have drawn the side view also without any problem. Only thing what you should not forget is there's a dotted line here, okay, of this edge. When you're looking from here, okay, all other edges can be seen, but this edge cannot be seen. Okay, that has been made dotted. That is at a distance of 15.5. That is, you take the projector directly from here. Take the projector from here. This edge, in fact, that is this edge, which cannot be seen from when you look from this direction. Okay, in that way, you have completed session 7. Session 7 on orthographic projection. Thank you very much for watching. Thanks a lot.